Alright, ladies and gentlemen, in the video we are going to be diving into complex conjugates. Alright, we're going to find out what it is, why are they important, and what are they used for. So, what's a complex conjugate? Let's say, for instance, we have a plus bi being a complex number. That's kind of our standard form, so we know. Right? It is true to say that a minus bi is considered its complex conjugate. Alright, well you told us it. Why is it important? Well, it's important for a number of reasons, because as we dive into limits and things like that, you're going to start seeing it's a way to solve limits algebraically in some instances. But specifically, what it ends up telling us is that, if it'll move for me, the only two complex numbers can be multiplied and result in a real number is when they are complex conjugates. I'll say it one more time. The only way we can take two complex numbers, basically fake numbers, right? I don't want to say fake, but you know what I mean. Basically fake numbers and being multiplied together, somehow, some way they give us a real number. What? How is that possible? How can two imaginary numbers come out together to give us a real whole number? This is crazy to think about. One of those things about math that absolutely blow me away, because how are you going to have two imaginary numbers, things that don't even exist in the real number world, all of a sudden somehow give us a real number when it's all said and done? Well, let's take a look here at how it works and why it does. Well, think about a plus bi times a minus bi. These apparently are complex conjugates according to the definition. So let's multiply them together. We get a squared plus a times negative bi, which is a negative abi, and then bi times a, which is a positive abi, and then a negative b times b is b squared times I squared. Well, boom, boom, that cancels on out. A squared, well, I squared is a negative 1. So really, this is a positive b squared. Ladies and gentlemen, looky there. A squared plus b squared will be a real number. How do we use it? Well, we use it as a way to rewrite some things in standard form. So I want to rewrite 2 plus 3i and put it into standard form. How does that look? Well, we're going to go ahead and multiply by the complex conjugate, because with multiplying by the complex conjugate, it's going to allow us to, in the end, get a real number. That's what happens, right? So we're going to multiply. In this case, we're going to look at our denominator, right? We're going to look at the denominator, and we're going to multiply by the complex conjugate at the top and the bottom. So we're going to multiply by 4 plus 2i to the numerator and the denominator of this polynomial. All right, so what does that do for us? Well, we get 8 plus 2 times 2 is 4i, 3i plus 12i, and 3 times 2 is 6, so plus 6i squared. On the denominator, well, what are we going to end up with? Well, just kind of for our purposes, I'm going to go all the way out with it. We get 16, we get 4, and we get a positive 8i minus 8i, and then we get a negative 4i squared. Cancel, cancel. We get 8 plus, in this case, 16i, and then minus 6 divided by 16. Negative, negative makes a positive, so that's a positive 4. So continuing to move, 8 minus 6 is 2, so 2 plus 16i over 16 plus 4 is 20. However, that is still not in standard form. Good news is we're pretty close. We had to make sure we do put it in standard form. So standard form would look like 1 over 10 plus 16, 4 goes into 16 4 times, and 4 over 5i. Now we're in standard form. A plus bi, two real numbers in that standard form of our equation. All right, guys? All right, ladies and gentlemen, so that's going to wrap it on up for this video in using the complex conjugate to write in standard form. On to the next one.